Hello all. In this session you will be knowing how to construct parabola general method by using AutoCAD software. Now let us take focus distance is equal to 50 mm, where for parabola E is equal to 1, nothing but we are going to mark vertex at the midpoint. Vertex will be taken at the midpoint, so that is equal to E. Let us say 2 by 2, so that is equal to 1. So let us construct. Let me take a line. I'll just click on F8. A vertical line is drawn, followed by I'll draw the axis line, L, enter. You can start from the midpoint or you can start anywhere on the vertical. It is not compulsory that you have to start from the midpoint. Okay, now I'll take it as 50 because 50 is given in the question. This is a 50 mm line length. Okay, this is a 50 mm line length. Now this 50 has to be divided into 5 parts in general. For example, if it is eccentricity, 2 parts will be taken from the focus. This acts as a focus. Let me give that 1, 2, enter, enter. Yes, let me write the text here. This becomes the focus. This point becomes the focus. I'll copy paste it here. This point is focus. Let me move further. M, enter. To move, this point is focus. Let me create a point so that you'll understand better. PO, enter, at this point. Okay, this point is focus point. The F is the focus. Alright, now for ellipse we'll take 2 parts from the focus to mark the vertex point. But for this case that is not required. Directly you can place a point at the midpoint. Okay, I'll say PO, enter, as we are dealing with midpoint. This is the midpoint symbol. It is showing it as midpoint. There I just try to place a point. Okay, no need to divide the 50 mm line into 5 parts the way we do for ellipse or for hyperbola. Now the overall distance is 50 mm. I am marking a midpoint here, means this half is to 0.5, this half is to 0.5 centimeters. Now again I'll take a line, and from the center of midpoint I'll just drop vertical of distance 25 mm. Escape, done. Okay, now let me mark this as E. Let me increase the number. Mark that as E point. Now this point is V. This is, I'll just copy again. V. Alright. Vertex point. Now this VF is equivalent to VE. Let me place a point here also so that you have a clarity point. Alright. This distance VF should be equivalent to VE. Now if you want, you can increase the length of the directrix. The flexibility of using AutoCAD or any other tool by avoiding the conventional representation or conventional way of drawing is at any point of time you can edit. It becomes very easy. Now I'll draw a straight line passing through, I'll just remove ortho so that I can go with some angle, something like this. I'll join with this point. Okay, just I need to take the extension of the point now. Let me draw one more line starting at the edge focus and ending at some infinite distance. So now again I'll take a line from here. I'll just draw one infinite distance vertical. The only reason to draw that vertical is I want to extend this line which is passing from E. Okay, this is the only idea. Let us name the axis also. Let us name the axis. I'll name it as this one. Here one more. I'll name this as CD, C, and this as D. That will make it capital. This is capital. Done. Okay. So as this is axis, select and keep it in axis format. Select, keep it in axis format. It looks like an axis. If you zoom out and see, that is visible. At any point of time you can make changes. Now I'll just mirror this line to the other side. Alright, this is how you'll get. Now other than this, other points like every other things are similar. Now in between I'll try to divide this into number of divisions. This line you can use divide or you can offset also. I would like to take offset, enter, through, done, this one, enter. Okay. O is the command for offset, through, done. Let us take this line with an offset distance of already it is placed at a distance of 25 from the focus, so let me take it as some 10. This is one point. Again I'll repeat the task. Means I'm trying to place number of divisions at an offset distance of 10 each. I'm maintaining equidistance. It is not compulsory to maintain equidistance all the time. It could be unequal also. Anything is okay. Now all these lines should be extended till the inclination. EX double enter is the command and select them all. Okay, you can remove unwanted. Unwanted can also be removed. Now again I'll repeat O, enter, because I want more copies. 10, 10. Okay, EX double enter. So I want them all to be extended. EX. I'll enlarge, then EX. These are the lines I would like to extend. Similarly, you can take a mirror of all these lines, but that is not required as we are using a tool, because conventionally when you draw on a sheet of paper, the same verticals need to be projected to the other side of axis line also. Now this is a basic thing done. Now I'll take a circle. I would like to see the radius, this radius. Okay, means again I'll copy this one. I'll try to place it here. Control V. Here is one. Control V. This is one more. This is one. Okay, now I'll just try to edit all the points. This point I'll take it as 1, this as 2, 3, 3, and this as 4. If that is 1, then this becomes 1 prime, this becomes 2 prime, this becomes 3 prime likewise. Okay, now you can take it as a prime. Now 1 1 prime means this line 1 1 1 1 as the radius, F as center, cut the same line 1 1. So for that, what I do, let me color this with some blue, and if you want you can increase the thickness also, but that is not required now. So now I'll just move the circle to the focus. Now this intersection of the circle and the line, PO, enter. This point you need to mark. Alright, now after this I'll move the circle again to the second division. Then I extend this, move, enter, or else directly also you can move this particular point to the focus, because always focus acts as a center. The intersection of the circle and the line 2 2, there I need to place one more point. Similarly, take the circle to third division and extend this radius or diameter till 3, then move it back to the focus. Alright, now if you'll see, here is the intersection point, PO, enter, place the intersection point. Similarly, again select the circle, take the circle to the fourth division and increase the radius till 4, move it back to the focus, because focus always acts as center. Now when you look at these two, here is the intersection, PO, enter. I would like to place a point where intersection of 4 4 and the circle is happening. Again I'll select the circle, I'll take it to the fifth division. I'm not giving all the notations, which is a wasteful task, just to make you understand. I'm doing the practice. Done. Okay, now again move it back to the focus point. Now 5 5 now it is intersecting somewhere, PO, enter. Okay, now if you look at the points, the point is starting somewhere here. Here it is starting, and it is keep on moving with respect to the inclination line only. It is not even not coming down. It is keep on going up only. Further, we'll try to take one more point. Now, if you would have watched my videos, previous lecture of ellipse, after fourth or fifth point, the point or the intersection is slowly coming down, but here it is not happening. The only reason is we took the midpoint as the vertex for parabola. That is the only reason. So it is no way it is going to come down. Okay, the intersection of 6 6, here is the point PO, just keep on going up. So if you take multiple divisions, if you take as many number of points as you want, but still the intersection point is not going to come down. This is the, after this is the next radius. Let me increase it till the intersection point. Again, I'll just move it back to the focus. Select, circle, select, keep it in the focus. Intersection of those two, PO, enter, here is the point. Okay, so this is how the curve is going to be. Select again, move it back to the next radius, or else directly I'll go with the last one, okay, without wasting any time. So now this point I'll just extend it. I'll take the circle back to the focus, the intersection of the circle and that line. Have a look. This is that intersection. PO, enter. This is the point I took. So done. This is how it will be. Okay, this is how the points are going to be. Now we need to copy. Now let me delete this circle and copy, mirror. I would like to mirror this point, this point, this one, all the points which are created in the circle and the focus. I'll select them all and I'll try to mirror it with respect to this axis. No, have a look. Same points are going to the other side also. Actually, this line is also not required for this case because that is required when you draw it on a sheet of paper or a drawing sheet. Okay, now I need to join them all. SPL, spline is the command that you could see here also. You find it. Now I'll try to join them all. 1, ortho off, keep it off. 2, 3, 4, 5, 6, 7, 8, 9. Now these are the intersections made. So now it will start the curve, either it is ellipse, parabola or hyperbola. It is going to start at the vertex point. So here it is meeting. This is the next point, next one, or else you can copy. No need to select also. You directly copy you can mirror it. Other one curve you can draw, other side you can simply mirror the curve. So no way those two end points. Now if I'll click on close, this is how it is going to be. And now I'll use now what I'll try to do, have a look. Simply I'll select the curve, I'll increase the thickness by some number and change the color just for your understanding purpose. Alright, now I'll try to mirror this with respect to and this point, no. Have a look. This is how a parabola looks like. If you keep on divide the axis line, if you keep on mark the radiuses, still this curve is not going to come down. This is how it look like. All right. Now this is the point P1, P2, P3, P4. Similarly, you have to represent 1, 2, 3 numericals here, 1 dash, 2 dash on the top. All right. Now only the curve has to be dark in color. Other things you have to make it maybe I'll just take this color, keep it in this format, 2H format. Okay, light color, so that only the curve will get highlighted, not the lines. Have a look. Now I'll just fit it to the screen. Z enter, A enter is the command. This is how it look like. Okay, now the same curve can be seen on a sheet. Okay, here the orientation is wrong. That is the only reason. You need to change this. And this one. Yes, this is how it look like. Have a look. Now the same can be printed also. Whatever got drafted can be printed. I can pan it, I can fit it to the screen. Okay, same thing can be fitted to the screen. Same thing can be printed also. Any sketch, not only parabola, any complex sketch, any layout can be printed also by using these sheets. Size of the sheet can also be fixed. Okay, this is how a parabola is constructed or generated through a software called AutoCAD. Okay, this is a general procedure. This is all for the session. If you have any queries, you can comment in the box given below. Thank you for now.